All right, guys, so we're going to go over the review sheet today. Your test is tomorrow. Now, the first thing we're going to look at is direct and inverse variation. Now, direct variation, the main equation we have is y is equal to a times x. We could say x is equal to a times y. Both of those are the same thing. The other variation that we have of this is y over x is equal to a. We could say x over y, y over x, same thing. Now, inverse variation, our main equation is y is equal to a over x. We could say x is equal to a over y. Either one works. And our other variation of inverse is x times y is equal to a. So if we look at the first one here, y equals 7x would be direct. X equals 6 over y is inverse. Is neither. Exactly, because of the plus. Plus is kind of the big giveaway for neither. Number 4 would be inverse. Any questions on these here? All right. The next set that we're looking at is addition and subtraction. Adding and subtracting. And we can add or subtract fractions if the denominators are the same. So if we look at number 7, the denominators are already both the same, A and B. So we can add the numerators. U plus 6u is 7u. Negative v minus 3v is negative 4v. So we get this here. And that's really it, because if the denominator is the same, we add or subtract the numerators. We do need to be careful with subtraction, because we do need to change the signs of what we're subtracting because of the subtraction sign. But other than that, that's about it. Put that one there. Questions on number 7? Questions about number 8? So, the denominators are already the same. Yes, and we can factor them. Now, we can factor them now, or we can wait to the end. We're going to have to factor them eventually. So we can go on and factor them now. A plus 2 and a plus 1. Because our signs are the same, match sign of the middle term. Factors of a squared are a and a. Only factors of 2 are 2 and 1. So we get this here. And well, since they are the same, they're going to be the same on the other side too. Four plus a and 4a plus 1. Since the denominators are the same, we can add the numerators. So we have 4 plus a plus 4a plus 1 over a plus 2 times a plus 1. Now at this point here, we can combine like terms. 4a plus a is 5a. 4 plus 1 is 5. Now we could have written it as 5 plus a, 5a, or 5a plus 5. Either way, we get the same thing. Now this here would be the final answer as long as nothing factors. But the numerator does have a greatest common factor of 5. And if we factor it out, we get 5 times a plus 1 over a plus 2 times a plus 1. So there is a greatest or a common factor of a plus 1 on top and bottom that would cancel, leaving us with 5 over. So we try to see, once we finish adding and subtracting everything in the top of the fraction, we want to see if we can factor it. If we can, we need to factor it and then simplify from there. Any questions on 7 and 8? Now these here on the test, there's a good chance they will simplify, but problems like number 9, where we have to make the denominators be the same, they're not likely to simplify, but it's always good to check. Now if we look at number 9, we need to make the denominators be the same. So the one on the right, what do we need to do? We need to multiply top and bottom by x plus 7, 7 plus x. And the one on the right needs over x minus 8. Because we need to make the denominators be the same. Now we don't have to multiply x plus 7 and x minus 8 out because it's going to stay the same and we're going to need to factor it anyway, so it's fine there. However, the numerators, we're going to have to actually subtract them. We're going to have to combine like terms. So we'll need to distribute this out. X times 3 is 3x. Negative 8 times x is negative 24. Here, 4 times x is going to be 4x. 4 times 7 is going to be plus 28. Now the first one, our 3x minus 24, is going to say the same. We can put parentheses around it if we want, but the signs are not going to change. However, the signs for our 4x plus 28 will change because we are subtracting. Because really what we have is 3x minus 24. If we distribute this here, we have negative 4x minus 28 over x plus 7 times x minus 8. Now at this point here, we can combine like terms. 3x minus 4x is 24 minus 28. Is there a greatest common factor between x and 52 other than positive negative 1? No. We could pull the negative 1 out, but it's not going to help anything because we don't have anything that would match up with x plus 52. So that there is the final answer. Questions on any of these here? Questions on any of our addition or subtraction? I will say one not as complex as 10. 10's a problem as complex as 10 isn't going to show up. We're not going to have a whole bunch of factoring we're going to do with addition and subtraction. So any questions on these here? (11, 12, 13) are not going to show up on the test, incidentally. Questions on 14 with multiplication? Do we want to look at 14, 15? Okay. So 14, 15, 16. 14. Whenever we multiply two fractions, two rational expressions, the first thing we need to do is factor every single one of them that is factorable. Now the x plus 7 on top, x minus 8 on bottom are as simplified as they get. We don't have to do anything to either one of those. So we need to factor the 7x plus 35. And again, 7 is the greatest common factor that we can pull out. Because whenever we factor, I would always look for greatest common factor first, especially if we have two terms. Look for it first. Then we can go to our sets of parentheses. 7 times x plus 5. That is as simplified as it gets. So the last one that we have is x squared minus 3x minus 40. There is no greatest common factor, so we can do two sets of parentheses. Exactly. We would have plus and minus, x and x for x squared. Then 8 and 5 would be the factors of 40 that we want. We want negative 8 and positive 5. Mainly because, again, since we don't have a number in front of x, we want the bigger factor of 40 to be negative, which would be our 8. 5 would be the positive, but also with that, it does give us an x minus 8 in common on top and bottom. And when we multiply them together, the x plus 5 and x plus 5 would be in common, leaving us with x plus 7 over 7. Now, if we do have a multiplication or division problem that's already with parentheses already factored out, just go on and start doing them operations. You don't have to do anything factoring-wise with it because it's already factored. Kind of like the starting problem that ended up being 1 on the last test, if you remember that. Already started in parentheses. Just start doing simplifying and going from there. 15 or 16. We want to look at either one of these here. Do you feel good with multiplication? Yes? 15. Now the first thing we want to do is factor. I'm going to start off with x squared minus 25. We do have two terms, but there's not a greatest common factor between them. Because x squared is a perfect square, 25 is a perfect square, and they are being subtracted, so we do have a difference of perfect squares, which would give us x plus 5, x minus 5. X minus 9 is again a difference of perfect squares. X squared would be x and x, 9 would be 3 and 3. So we can look at x squared plus 6x plus 9. Since it's 9's positive, signs are the same, match the sign of the middle term, so x and x, or plus and plus. X squared would be x and x, and then 9 would indeed be 3 and 3. And the last one, x squared minus 3x minus 10, the 10 being negative, means the signs are opposite. Factors of x squared are 5 and 2 would be our factors of 10. And if we want the middle term to be negative, the bigger term for 10 would be negative. And we can say that because the numbers in front of x are both 1, so they're the only factors that come into play. We multiply them together and simplify what's in common on top and bottom. So x plus 3 and x plus 3. We also have x minus 5 and, which leaves us with x plus 5 times over x minus 3 times x plus 2. With all the multiplication and division problems, something will simplify. We won't just have it factored and then multiply together. Something will simplify on top and bottom. Any other questions with multiplication? $18. So again, whenever we divide, we keep the first one the same, change it from division to multiplication, and flip the second. Keep, change, flip. And after we do that, we're essentially going to treat it the exact same as we would for multiplication. We need to factor any and all parts of it that are factorable. The x plus 3 is not factorable. The x plus 2 is already simplified. It's not factorable. 8x squared is a single term. We can't do anything to it. However, 8x cubed plus 16x squared has a greatest common factor of 8x squared. And if we factor that out, we're left with x plus 2. Now we do have something in common on top and bottom, which is 8x squared. And what that leaves us with is x plus 3 over x plus 2 times x plus 2. Now we could write this as x plus 3 over x plus 2 squared. Either one of these works. So the answer key does need to be changed. This is the correct answer. I have the wrong one on the back. Any questions on 18 before we look at 19? 19. Again, keep, change, flip. So the first thing we do is we rewrite it as multiplication and do our keep, change, flip. Now we factor. Well, I'd start off with our x squared minus 64. No greatest common factors, but it is a difference of perfect squares. So we have our plus and minus. X squared would be x and x. 64 would be 8 and 8, because 8 times 8 is 64. 2x squared minus 18. Is this a difference of perfect squares? They have a greatest common factor of 2, so we'll start off by factoring it out. If I take 2 out of 2x squared, we're left with x squared minus 9. So we'll do that next. So x squared minus 9 is a difference of perfect squares, but we'll factor it here in a second. Now our numerator, 4x squared minus 16x plus minus 84, not plus. Yes, it has a greatest common factor of 4. So we're going to divide every single term by 4, which will give us x squared minus 4x minus 21. And the last one has a greatest common factor of 2, so we can pull it out, giving us x squared plus 16x plus 64. We haven't had too many, especially going back over it again, where we had a greatest common factor in more than one. But here we had 3. So a lot of times, if we do have this come up, I'd pull the greatest common factor out first before I start factoring everything else. Like with the now x squared minus 9. So I'll pull the 2 out first and then factor x squared minus 9, which would be x plus 3 and x minus 3. Difference of perfect squares. X squared is x and x. 9 is 3 and 3. It doesn't matter which one we do next. I'll do the x squared minus 4x minus 21. Since the 21 is negative, our signs are opposite, positive and negative. Factors of x squared are x and x. Which one's positive, which one's negative? 3 is positive, 7 is negative, because we want a middle term that's negative, and we can say the bigger one of the factors of 21 needs to be negative, because the numbers in front of x are both 1. Last one, x squared plus 16x plus 64. So we would have plus and plus, x and x, and then 8 and 8. Because 8 times 8 is 64, and 8 plus 8 is 16. And we multiply these together and cancel out what's in common on top and bottom. Nope, that needs to be fixed. I have a feeling y'all did have it as x plus 8 and x minus 8, yes? I, for some reason, miswrote it as plus and plus, but it should still be plus and minus. So 1 x plus 8 cancels out on top and bottom. We also have what? On top and bottom. So, parentheses wise, on top we have x minus 8. X. And then we have the 4 out front, yes? In the denominator, well, we have 2 times 2, which is 4, times x minus 3 times x minus 8. Plus 8, thank you. Otherwise, it would have canceled. Is that it? Because 4 divided by 4 is 1. Really, that's it. Because you can cross them out and rewrite it again. I just erased the whole thing.
She's like 8, and she told me, she's like, you're so dumb. You don't even know what 10's 1 is. And I was like, oh yeah, what is it? She's like, it's 0. She said it so confidently.
Questions on this here? We good with division? Solving. 20 or 21? 20. So, again, on the test, if there are restrictions, just like the first test, it's going to signify it. Either in the instructions, like we saw last time, solve the following equations, check for restrictions, or next to it. If it doesn't have that anywhere near it, there is not going to be any restrictions. So for this problem here, there are no restrictions that we have to take into account. Because here, if there are restrictions, it would be 3 or 4. And I don't think there are restrictions for this one here. And we'll see. But going from there, we're going to multiply everything by an expression to get the denominators to cancel. So one thing I know for sure we can multiply everything by is, because it'll make those two cancel. Then the next thing we can multiply everything by is x minus 4. It'll cause these two here to cancel. And after we do that, we don't have any denominators left, so we can go on and solve. So what we have left is x minus 3 times x minus 3 is equal to 4 times x minus 4. And at this point here, we're going to factor x times x is x squared. X times negative 3 is negative 3x. Negative 3x. That's 9. Distribute the 4. 4 times x is 4 times negative 4 is negative. Now at this point here, we can combine like terms. Negative 3x minus 3x would be negative 6x. So we had x squared minus 6x plus 9 is equal to 4x minus 16. Yes. Because whenever we have an x squared term, we need to get it equal to 0. Then we can subtract 4x. Really, we could have done that in one step, but it's fine doing it in 2 as well. So once we get everything on the same side, we have x squared minus 10x plus 25 is equal to 0. Now we just need to solve this for the value of x. That makes it equal 0. We can factor it or we can graph it, either one. If we factor, there is no greatest common factor. If there is one for solving, divide it out of everything, as long as it's not a variable. If everything had a greatest common factor of 2, we divide the whole thing by 2, and we'd get our answer. Now here, since the 25 is positive, the signs are the same and match the side of the middle term. Minus and minus. Factors of x squared are, factors of 25 are 5 and 5. And now that we have two things multiplied together to equal 0, one of them must be 0. So we have that x minus 5 is 0, or that x minus 5 is 0. For the one on the left, we would add 5 to both sides, telling us x is equal to the one on the right. We would add 5 to both sides, telling us x is equal to 5. So those are our two solutions. And our restrictions, if we had listed them, were 4 and 3. They're not there. So our solution is 5. Questions on this here? Now we could have graphed x squared minus 10x plus 25, and it would have intersected the x-axis at 5, wouldn't cross it, even multiplicity. But that is it. Any other questions on number 20? Questions on 23, 24, 25? 25. Now, whenever we're solving, we do need to make sure all the denominators are factored as far as possible. So x squared minus 4x minus 12 does need to be factored. We have our plus and minus. Factors of x squared are x and x. Positive 2 and negative 6. And that is kind of nice, because if we were trying to simplify everything down, there aren't any restrictions on this here, I do know that I'll need to multiply everything by x minus 6. In the far one on the left, the x plus x minus 6 and x minus 6 would cancel. The one on the far right, the x minus 6 and x minus 6 would cancel out. What else do we need? Now the one in the middle, the x plus 2 and x plus 2 would, and the last denominator would cancel out. And the way that x squared minus 4x minus 12 factored, the reason I said it was nice, is that it didn't add any factors that we had to multiply everything by in solving. We already had them. Now what that leaves us with is 2 times x plus 2 plus 7 times x equals x squared minus 12. Now, if you already multiplied it out, there's nothing wrong with that. So if you had already written it as 2x plus 4 plus 7x minus 42 is equal to x squared minus 12, if you just jump from here to there, that's fine. If you feel comfortable doing that, you can go on and do that. If not, go on and write it out as our step right here. Yes, thank you. Because that would change things a little bit. Now at this point, we can combine like terms. 2x and 7x is 9x. 4 minus 42 is 38. Now again, we do have an x squared term, so we're going to need to get this equal to 0. I normally try to move everything towards the x squared, especially if the x squared term is positive. Negative 12x minus 9x is going to be negative 21x. And then we will add 38, telling us 0 is equal to x squared minus 21x plus 38. Any questions on this here? Now at this point, we could factor it or we could graph it. I'm going to graph it. I'll also factor it. Figure that out. X squared minus 21x plus 38, yes? Or is it minus 38? Okay, good. So we do see that it crosses one time at 2, yes? Well, 38, what's the other factor with 38 that has 2? 2 and 19, yes? So by graphing, we can say x is equal to 2 and x is equal to 19. Now, if we had factored it, since the 38 is positive, our signs are the same, match the sign of the middle term, minus and minus. Factors of x squared are x and x, and we would have 2 and 19. Now that would tell us that x minus 2 is equal to 0. X minus 19 is 0. Here we would add 2 to both sides. Here we would add 19, telling us x is equal to 2, and x is equal to 19. That's it. Questions on any of this here? We can look at one of the ones with restrictions. We can look at 28 or 27. 28. So if we look at this one here, again, we will need to list all of the restrictions, all the values of x that are going to make the denominator be 0. And we also need to factor any denominators that do appear. So x squared minus 2x minus 3. Since the 3 is negative, our signs are opposite. Factors of x squared are x and x. Factors of 3 are 1 and 3. It works out that we do have x plus 1 and x minus 3. Now we do need to list our restrictions. What x cannot be. Negative 1 or positive 3, because if we have negative 1, x plus 1 is going to be 0. If we have negative, or if we just have 3, x minus 3, 3 minus 3 would be. So if we have 1 or negative 3, those will not work. Now we can multiply everything by x plus 1 and. Now on the far left, the x plus 1 and x plus 1 would cancel. The middle one, the x minus 3 and x minus 3 would cancel. And the last one, both of them are going to cancel out. And what that leaves us with is 3 plus x times x plus 1 is equal to negative 2x minus 6. Well, the x minus 3 really doesn't need the parentheses. Here we can distribute the x, giving us x squared plus x is equal to negative 2x minus 6. We can combine like terms, which would give us x squared plus 2x minus 3 is equal to negative 2x minus 6. We need to get it equal to 0, so the next thing we can do is add 2x to both sides, which would give us x squared plus 4x minus 3 is equal to negative 6. Then we could add 6 to both sides. So we have x squared plus 4x plus 3 is equal to 0. Factor or graph? X squared plus 4x plus 3. Graph. So we see the two spots that intersected. If we go second graph, we're going to have to scroll up. We would have, yes. And these here are our two solutions, yes? Negative 1, it does not work, because negative 1 and positive 3 were our restrictions. I will do 27. I do want to ask about 29 through 32 first before we do it. 29 through 32 is just simplifying. Factor it and cancel out what's in common. So x squared minus 3x minus 10, x and x plus and minus 2 and 5. X squared plus x minus 2 would actually be x plus 2 and x minus 1. So on any of these here with simplifying, the first thing you're going to do is factor top and bottom as far as possible. Well, x plus 2 is in common on top and bottom, which just leaves us with x minus 5 over x minus 1. And that's it. So with all these simplifying, all you got to do is factor top and bottom, either being a greatest common factor, 2 sets of parentheses, simplify. Do you feel good with 29 through 32? 27. Well, we know x cannot be positive or negative 1. Now we will need to factor 1 are denominators. Because the x squared minus 1 is a difference of perfect squares, giving us x plus 1 and x minus 1. Now at this point here, we know we can multiply everything by x plus 1 and x minus 1. And in the first one here, the x minus 1 and x minus 1 would cancel. The middle one, the x plus 1 and x plus 1, would cancel. And in the last one, everything would cancel, leaving us with x plus 7 times x plus 1 plus x minus 1 times x minus 1 is equal to 4. Now at this point here, we do need to distribute. X times x would be squared. X times 1 is plus x. 7 times x is plus 7x. And 7 times 1 is plus 7. Here we would distribute x times x is x squared. X times negative 1 is negative x. Negative 1 times x is negative x. And negative 1 times negative 1 is plus 1. At this point here, we can combine like terms. X squared plus x squared is 2x squared. X plus 7x is minus x. 7 and then 6x. We can combine all those at once. We don't necessarily have to do it in 2 steps. 7 plus 1 is plus 8 is equal to do we want to factor or graph it? Factor. We'll do both. So factoring, is there a greatest common factor? 2. This is the first one we've had that actually did have a common factor as a number. We can divide the whole thing by 2. Because 2x squared divided by 2 is x squared. 6 divided by 2 is 3. 4 divided by 2 is 2. So we'd have plus and plus, x and x, 1 and 2. Since we have 2 things multiplied together to equal 0, one of them must be 0. X is negative 1. And negative 2 can't. Now, if we graphed it, because we had 2x squared plus 6x plus 4, yes? And it crosses at -1 and -2. Also, if we'd have done x squared plus 3x plus 2, crosses at the exact same spots. Everything else is different, but it does give us the same solutions.